All right, so the equation of a circle. On your test, you're going to be asked to tell me the center and the radius of a circle. So in order to do that, I kind of want to show you why it is what it is. So we're going to end up plugging in a center and a radius. The formula of a circle is right here. So you want to write this down. I know it's a lot of letters, and you're like, I don't know what an H and a K and an R are doing in our math class, but you'll see. Just write it down. X minus H squared plus Y minus K squared equals R squared. Guess what? The center is HK. So where you see an H, that's where the X of the center is going to go. Where you see a K, that's where the Y of the center is going to go. And then what do you think R represents? Radius. Okay, so we're just going to plug into this formula. The three things I've outlined are the only things that change in this formula. So I'm going to write the skeleton of it. All right, so I left the blanks for the three things that we're going to plug in. We're going to plug in a center of -4, 6. So this is my H and this is my K. When I plug in -4, what does it look like it happens? It turns positive. It'll become X plus 4 squared. All right, and then my K, which is 6, gets plugged in right here. So it looks like Y minus 6 squared. And then what is my radius? 9. So when I plug in 9, what is 9 squared? 81. That is all you are asked to do. You're not solving for anything. It just asks for you to write the equation of the circle. So what you're going to be doing is you're going to be given the equation, what we just found. You'll already be given it and asked to find the center and the radius. The center will always be the opposite signs of what's inside of the parentheses. So the center of this one is -4, positive 6. It's because when you plug it in, it looks the opposite of what it actually is. And then you're going to be asked to find the radius. So you'll take the square root of what's on the right side of the equal sign. So that's all you're going to be asked to do. We're just doing this to kind of practice. For the second, we're going to do the same exact thing. So we have X minus squared plus Y minus squared equals my radius squared. All right, what is the X of my center? 8. Then what is my Y? 0. Then my radius is 4.2. All you do is you plug them into the formula. Can you simplify X minus 8? No. Can you simplify Y minus 0? Nope. If you have 5 watermelons and I take away 0, how many do you have? You still have 5. So what is Y minus nothing? Y. I don't know why that's the hardest for students. And then equals 4.2 squared, 17 point something. What?
What if we kept it Y minus 0? That's wrong.
It's just not simplified, so you get a couple points off. What is 4.2 squared?
8.4.
No, it's 17. It's, no.
16?
0.64, you said? 17.64. Okay. Because 4 times 4 is 16. All right, and then the last, going to make this smaller again. The last, you do the same exact thing. Plug in X minus squared plus Y minus squared equals my radius squared. I wrote it like that for a very particular reason. What is my X? -9, so a negative of a negative makes a positive. What is my Y of my center? -3, a negative of a negative becomes a positive. All right, and then I have 3 square root of 2 squared. When you plug this into your calculator, you have to put parentheses, because if you don't, you're going to get 6, and that would be wrong. You need to get 3 squared is 9 times 2 is 18. You need to get 18. Am I right or am I right?
None of the above.
So look, if you plug in this, You're telling your calculator 3 times the square root of 2 squared. What is the square root of 2 squared? 2. So you'd be telling your calculator 3 times 2, which is 6. This is not what you want to be telling your calculator. You want to tell your calculator to square both of them. 3 squared is 9. Square root of 2 squared is 2. 9 times 2 is 18. So if you did not get 18, you still plugged it in wrong. You plug it in 3 square root of 2 squared. If you plug it in the way that I just wrote it, then it's going to read it as this top portion, which is correct. Questions on how to plug that in? Pardon me? You put parentheses and the squares on the outside of those parentheses? Let me check. Here's the second portion. This is what you're actually going to be doing. You're going to be asked the center and the radius. Look at that. This is 18. Wonder how that works.
What you did wrong? What you did wrong?
He put this square in the wrong spot. Number 1, identify the radius in the center. Remember that the formula used to be x minus squared plus y minus squared. So what did we have to plug in to just get x squared? 0. And then to get y squared, we had to plug in 0. This is the original formula. This is the simplified form. So it's asking me to identify the center. What did they have to plug into this original formula to get x squared? This is like a blank here. They had to plug in a 0 and a 0, and it simplified to x squared plus y squared. To find the radius, 4 equals r squared. You're going to take this, that's not squared. You're going to have to take the square root of it. So the radius is 2. And the center was 0, 0. Of the second, the center, remember it's going to be the opposite sign because it used to be x minus squared. So what did they have to plug into this parentheses to get plus 3? Negative 3. What's your question, Anna?
So basically to the opposite.
Opposite sign, yep. All right, and then y plus 3 squared, what did they plug in? Negative 3. And then to find the radius, you take the square root of what you have. What is the square root of 81? 9. And of the last, the center. What is the x of the center? Positive 5. And then what is the y of the center? Negative 2. It's always going to be opposite signs because when you're plugging it in, all right, that minus is going to make it the opposite sign of whatever you plugged in. All right, and then my radius, you do the square root of 48. You're going to leave it in radical form. This would be 16 times 3. So 4 square root of 3. So leave it like that.
How did you get the negative 3s?
Because when you plug into the formula, this used to be x minus in the formula. In order to get a positive 3, in order to get a positive number, you would have had to plug in a negative number because a negative and a negative make a positive. All right, and then you're going to be given a photo or a graph, and you're going to be asked to tell me the equation. All right, so what are the 2 parts of the equation that we need to know? We just found them, the center and then the radius. So you would need to tell me what the center is. It's drawn in by a dot. What is the coordinate point of this center? 1 and then negative 1, 2, 3. Negative 3. So what do you think we do with that? Plug it in. Plug it in over here, we get 1, negative 3. When you plug in a negative, what happens here? Becomes a positive. And then my radius. The radius is the distance from the center to the edge. What is the distance from the center to the edge all the way around? How many?
Wait.
2. 2 digits. 1, 2. 1, 2. 1, 2. Yep. To the edge of the circle is 2. So, what's 2 squared? 4. So So that would be the equation. All right, these are the two things you're going to be asked to do. We will review them again tomorrow. It's not necessarily on your quiz, but I wanted to make sure you saw it twice at least before your test. All right, so we're going to review chapter 10. This is the first portion. It says, in the diagram, JK equals 15, KM equals 112, MN equals 98. Is KM tangent to circle J? In order for the line to be tangent to a circle, the line and the radius must form a right angle. So what line are we questioning right now? KM. All right, and then where's the radius? What's the name of the radius? JK. So they need to form a right angle in order for this line to be tangent. So what kind of shape does this look like? A right triangle. What formula deals with a right triangle? Pythagorean theorem. So we're going to plug in. I see JK is 15. What's the measure of KM? It's in the directions. 112. And then it says NM or MN, which is from here to here, which is 98. Which side is the hypotenuse? JM is the hypotenuse, but it only gave you the measure of NM. What is the measurement from J to N? 15. Why is it 15? Because it's the what? It's the radius. The radius is from the center to the edge. So what is the full measure of the hypotenuse? It's not 98.
Whatever 98 plus 15 is.
113. Once you have three sides, how can we figure out if this is a right triangle? We just talked about it. The Pythagorean theorem. What's my a squared and b squared?
15 squared, 112 squared
Mm-hmm.
equals 98.
Not equals 98 squared. It equals...
113.
Sorry, let me just write the formula first. So a and b are 15 and 112. You're going to have to plug this in because I don't know that off the top of my head. And then equals 113 squared. Just plug in the whole left side. What's 15 squared plus 112 squared?
Wait, so would you have to do all of that if you can just tell that 113 is...
You need to prove it to me because you could look like a right triangle and not be a right triangle. What'd you get for the left side?
1,000, wait, 12.
They got it already.
We got it. What's 113 squared?
Stop.
12,760.
So, is this a right triangle?
Yes.
So, is this line tangent?
Yeah.
Yes. So, I'm looking for yes, and then I'm looking for you getting to this point. What?
That's the proof.
Yes, this is proof. All right. We have this portion. This is called a central angle. What makes it a central angle? What about the center? That's not a full sentence.
V is in the middle.
Okay. Central angles have their vertex on the center of the circle. It's literally on the screen if you read.
No, you didn't.
Congruent. They're congruent to their arcs. Okay, so this is not the half double. This is a central angle. Central angles are congruent to their arcs. So looking at this picture in the diagram, XZ is the diameter. What does that tell me? Why is the diameter important? It goes through the center, but why does that help
Oh,
me?
it bisects. That bisects. But
It's one of their angles because it's
Oh, 180.
a semicircle.
Yeah, it's a semicircle. So XZ is 180 degrees because a full circle is 360, half the circle is 180, which would mean this other half is also 180. All right, so it says and ZVB, the angle ZVB, which is right here, is what, 68 degrees. So use that. Identify each arc as a major, minor, or semicircle. A major arc is greater than 180. Minor arc is less than 180. Semicircle is equal to 180. All right, make sure you read the directions because I mark off. If you don't read the rest of the directions, you don't know to tell me if it's major, minor, or semicircle. And those are easy points. What is the measure of arc ZB? 68. And then what kind of arc is it?
Minor.
Minor. I could already tell. Why could I already tell without finding it?
Because it's different.
Because it's two letters. All right, ZXB. So starting at Z, do I go to the left or right around the circle? To the left, ZXB. That's the whole circle, isn't it?
No.
It's almost.
Yeah,
You have
24.
68. So what can we do to figure out what the measure of it is?
Subtract it, don't it?
360 minus 68. Yes, Hunter?
Why 360?
Because a whole circle is 360.
Oh, I definitely would have did 180.
I thought I like the inside was 68 and the outside was 105.
What kind of angle is this? Central angle. 360 minus 68 is 292, which makes it what kind of arc? Major. All right, and then the last, it says ZBX. So starting at Z, we're going to go left or right around the circle? Or down, yeah. ZBX. That's a semicircle, which makes it 180. Semicircle. It will not break your pencil or your arm to write semicircle. Do not write semi. Capiche? Because a semi is a car. No. Semicircle. You watch me write a big old X over that. Thanks, but no thanks. Okay. So now at the top, you're going to be given problems that looks like this. In the diagram, Kn is the diameter. So Kn is diameter of circle P. The measure of arc JK is 4x plus 49. The measure of arc KM is 14 plus 9x. Find the measure of arc JM. So, when a diameter and a chord, what is the name of our chord here?
JM.
JM. So our diameter I marked in purple. Our chord is JM. All right. When they're perpendicular, what makes these two perpendicular?
The right angle.
The right angle. When they come together, they form a right angle. The chord is cut in half. So that means JQ is congruent to QM.
Oh, yeah.
P is the center.
My bad.
So everyone at least understand that portion.
Wait, can you say that again?
So if the diameter and the chord form a right angle, they're perpendicular. When they're perpendicular, the chord is then cut in half, which would make the left half congruent to the right half. If the line portion, the chords are congruent, that means their arcs are congruent to each other. So that means arc JK is congruent to arc KM. And what were we given? We were given the measure of arc JK and the measure of arc KM. So what can we do with them? Set them equal. I had a student earlier today, they set it equal to 180. They added them and set them equal to 180. They would need to start and end on the diameter. Is JM the diameter?
Yes.
No, it's not. It's a chord. JM, right here?
Yeah, you right.
It's a chord only. So it's not 180 degrees. It could be close, but it's not 180. So you do need to set them equal. Pardon me. Set them equal. Subtract 4x. Subtract 4x. Subtract 14. Get 35 equals 5x. So x equals 7. Is that what it asked for?
No.
No, what did it ask for? Measure of JM. Well, we know the measure of JK is 4 times x plus 49. So 4, we know what x is, it's 7. 4 times 7 is 28, plus 49 is 77.
Boy, somebody say
But you don't have to solve the other one, do you, if you know what?
If you want to make sure you did it correctly. They should equal each other. I've seen a lot of people make a mistake. I've seen a lot of people make a mistake here, and then they just plugged it in and then assumed. So it's just an extra way to check yourself. It asks for JM, which would be JK plus KM. What is 77 plus 77? 154. The last portion, this is an inscribed angle. Where's the vertex of this one? On the side. This is the half and double. All right, we all in agreement. Can I get a nod?
Wait. The half and double?
Yep. You see where the vertex is? It's actually on the circle. Whereas a central angle, what we were dealing with, it looked like a clock. The vertex was on the center of the circle. So central angle, congruent. Inscribed angle, they're half and double. Okay? So it asks me to find the measure of angle T. Angle T is right here. What arc corresponds with angle T?
52.
SR, which is 52. The angle is smaller. Does everyone see how it looks smaller than the arc? So use your common sense.
Half it.
We're going to half it. What is half of 52? 26. All right, then it asks you to find the measure of QR. QR is right here. I don't know if y'all can see. There's a Q. I ran out of room, so it's right here. Don't judge me. We're gonna find the measure of arc QR. So if you look at this, we don't have an angle that corresponds with it. What I would look at is the fact that you have a diameter.
You want to use that 45?
We're about to.
Oops.
But 45 will help you find TQ.
Oh, so you do 180 minus 1.
Well, not minus 45. So from T to R all the way around the semicircle is 180 degrees. So if you found, if you found arc TQ, which is going to be double of 45, what's double of 45?
90.
90.
Hey.
And then you subtract that from 180. And 180 minus 90 is 90.
So you don't really do nothing before the 5% double it.
The 45 help
You would
find
just
the
double it, yeah. In this one, you would accidentally get it correct if you didn't subtract from 180. But in most of them, this isn't going to be 90. This would be like 54 or 23 or something like that. And you have to subtract from 180, and that will give you the light blue. Go ahead and clear your desk of anything but a pencil and a calculator. Yes? Yes, trade your phone for one.
Can I borrow